Hello, everyone. I'm Michael from Math Together Canada, and today we'll discuss the answers to the 2025 Fermat Contest, and that was administered by the University of Waterloo, and it was intended for grade 11. And the official solutions that University of Waterloo wrote didn't come out yet, so we can discuss the answers before the solutions actually come out. This video will be split into two sections. The first section will be for problems 1 to 20, and there are 25 problems, right? So the second section will be the final 5. Let's get right into it. So for problem 1, this is easy, right? This is just 2 plus 10, which is 12. So the answer is D. For question 2, we have this survey and a graph of the results. So there were 3,000 people who were surveyed. Of those 3,000 people, 20% chose Friday as the favorite day of the week, right? So the answer is just 20% of 3,000, because like the number of people that chose Friday as the favorite day of the week, that's just 20%. We're given this 20% of the entire like student population, right? So 20% of 3,000 is 600. So the answer is B. Question 3 is easy, right? The solutions are just 3, 4, 5, all the way until 13. And the number of like solutions there are is 13 minus 3 plus 1, right? So that's just 11. Or you can manually count it to get 11 quickly too. Okay, so for this question, this is like basic algebra. So they're paid a total of $50, and Alfonso is paid $14. Therefore, Rachel and Christophe are paid 50 minus 14, which is $36. And Rachel is paid twice of what Christophe is paid, and they pay us a total of $36. So that means that like Christophe is paid like $12 and Rachel is paid $24, right? That's the only way for like a number and double that number to add up to 36. Right? So because Rachel is paid 24 and Christophe is paid 12, that means the answer is 12 because it's asking about how much Christophe is paid. And then for question 5, we need to find the area of the rectangle inside of this grid. So a full square has an area of 1 because the squares are 1 by 1. So the full squares have an area of 1, and then the half squares, they're just like half of the full square, right? So they have an area of 0.5. So the area of the entire rectangle, there are 6 half squares, and there's 1 full square. So the area is 6 times 0.5 plus 1. So the answer is that's 3 plus 1, which is 4. So the answer will be C. Okay, so the current calendar year, which is 2025, is a perfect square because it is 45 squared. And we want to find what the next square is. So the next square is obviously 46 squared, right? Because like you can't have like 45.3 like square. That's not a perfect square because a perfect square is like the square of an integer. The next integer is 46, right? So 46 squared, you can either find that manually to be 2116, and that will give the answer of 2116 minus 2025, which is 91. Or you can just find 46 squared minus 45 squared, which is equal to 46 plus 45 times 46 minus 45, which is equal to 91 times 1, which is 91. So yeah, the answer is 91, and we have found that in two ways. Okay, so here it's like a dart game, and it's like you can get either 1, 5, or 10 points, and you can try 3 times, and we need to find which value is not like obtainable. So yeah, we can just like test it for each of the answer choices. So 16, you can throw, like, you can get 5 points and then 10 points and then 1 point. So you can't get 16 points after like throwing 3 darts. So that's not the answer. 7 is you can get like 5 points and then 1 point and then 1 point. So that's also not the answer. For 11, you can get like 5 points plus 5 points plus 1 point. So that's like also not the answer. And for 20, you can get 10 points plus 5 points plus 5 points. So that's also not the answer. So the answer is 13, which is C. Okay, so the average of some integers is 18, and the average of 5 of these integers is 12. What is the average of the other 10 integers? So the sum of all 15 integers, that's like your average is 18, right? And there are 15 of them. So it's 15 times 18, and that will be 270. And the average of 5 of these integers is 12, right? So the sum of these 5 will be, the average is 12, and there are 5 of them, so it's just 12 times 6, which is 60. So that means the sum of the final 10, the sum of all of them is 270, and the sum of 5 of them is 60. So the sum of the final 10 will be 270 minus 60, and that is 210. And their average is just 210, which is the sum, divided by the number of integers, which is 10. So the average is 21. So that gives us the answer of B. And for question 9, so x squared minus y squared is equal to 72, right? As given, x squared minus y squared is also equal to x plus y times x minus y. And x minus y is 12. So the 12 times x plus y is 72. So x plus y is 72 divided by 12, which is 6. So the answer will be E. Alternatively, you can kind of like guess and check to see that x is equal to 9, and then y is equal to -3 to get x plus y equals 6. But this is the best and fastest solution. So there are this many students on like a class trip. So there are 50 groups. Each group has exactly 3 students or exactly 4 students. Yeah, so this is like a classic problem. It's like the chicken and duck and like how many legs there are given that they're, right? It's like one of those types of like classical problems. So if all 50 like groups are groups of 3, then we would have 50 times 3 groups of 3, right? Well, so then we'll have 50 times 3, which is 150 people in groups. But there are 186 students in total, right? So we have 36 students remaining that are not in a group yet. So we can just distribute these 36 students one by one into groups of 3 to make them groups of 4. So that means there will be 36 groups of 4. right? Because if we have all groups of 3, there will be 36 students remaining, and you just like put each of them into a group of 3 to make it a group of 4. So there will be 36 groups of 4. As there are 50 groups in total, there will be 50 minus 36, which is 14 groups of 3. So that's equal to m, and that's equal to n. So the answer m minus n is equal to 14 minus 36, which is equal to negative 22. So the answer is A. So now we have like the light bulb flipping question. So you can just like list out like the light bulbs for each of them. That's like the easiest like solution. So all light bulbs are off. So after Angie like flips every second light bulb, it's like off. It's like we can write down the light bulbs that are on, right? So after Angie flips the light bulbs, the light bulbs that are like 2, 4, 6, 8, 10, and 12 light bulbs are on, right? And then Bilal flips the switch for every third light bulb. So 2 like doesn't change, so remains on. 3, like the switch for 3 is flipped, so 3 is now on. 4 doesn't change. 6 used to be on, but now that the flip is switched by Bilal, the light bulb just got flipped off. So 6 is no longer on, right? And 8 and 10 are like the same as 2 and 4. They remain like unchanged. And 9 is now on because 9 wasn't on. And then 12 gets turned off for the same reason as 6. And then Chen X Hui flips the switch for every fourth light bulb. So yeah, so 2 and 3 like remain unchanged. And then 4 gets turned off as it is a multiple of 4. And then 8 also gets turned off as it is a multiple of 8. And then 9 and 10 remain on, and then 12 now gets turned on because it is a multiple of 4, right? So now there are 5 light bulbs that are on. So the answer is A. So now we can proceed by problem 12. We just gotta find the employee that has the highest like money per hour. And that's just like which one is like has the highest slope, right? Because if someone has a higher like money per hour and compared to someone that has a lower money per hour, then in the same like time in hours, the person that has the higher like money per hour will have like a higher slope, right? Because they're like like their the graph of how much money they earn based on how many hours they work uh is like a line, right? So you can see that A has the highest number money per hour because A has the highest slope, right? You can just like draw the graphs for each of them, and notice that this one, which is A, has the highest slope. So A is the answer. So for this one, this is just like this is just testing if you can expand like two terms, right? So x plus 2 times x plus t is equal to x squared, and this gives 2x and this gives tx. So x squared plus 2x plus tx plus, and this gives 2t. And this is equal to x squared plus bx plus 12, right? So we can compare like x squared, they're equal. this one is equal to this one, and this one is equal to this one, right? Because we want to like compare like the like terms, like for the one with x, the one with x squared, and the one without x. So 2t equals 12, so that means t equals 6. So that means 2x plus 6x is equal to bx. So 8x is equal to bx, so b is 8. So the answer for 13 will be B. So substance doubles in volume every minute. That means if we like reverse time, every minute we go into the past, the substance halves in volume. So at 9:20, the container became full. So that means at 9:19, which is 1 minute in the past, the substance halves in volume. So half of a full container is half of a container. And 1 minute before that, which is 9:18, the substance halves again, right? So half of a half container is a quarter of a container. And the problem asks, when did the container become 1/4 full? So yeah, the answer will be 9:18, which is E. So we need to find the smallest 5-digit positive integer that's divisible by 12, 13, 14, and 15. So if it is divisible by 12, 13, 14, and 15, then it must be divisible by their LCM, right? This is just this is like a template like LCM question. So we can find the LCM of 12, 13, 14, 15. So 12, you can prime factorize it as 2 squared times 3. 13 is 13. 14 is 2 times 7. And 15 is 2 times 3. The highest power of 2 is 2 squared. The highest power of 3 is 3. The highest power of 5 is 5. Yeah, sorry, 15 is equal to 2 times 5, not 2 times 3. And the highest power of 7 is 7, and the highest power of 13 is 13. Now you just multiply them all together, and then that gives us that the LCM is equal to 5,460. And the smallest 5-digit positive integer that's divisible. So any number that's divisible by all 4 numbers must be divisible by 5,460. And 5,460 isn't a 5-digit positive integer, but double that, which is the next like smallest divisor of 5,460, which is 10,920. Works, right? That's a 5-digit positive integer. So as such, that is the smallest 5-digit positive integer. And we're asked for the hundredths digit, which is 9. So the answer is D. Okay, so this rectangle has an area of 224 and semicircles are drawn inside of it. The shortest distance between the semicircles is 2. So what we can do here is we can like notice that the all formulas for like semicircles or circles, they involve r, which is the radius. And the center of a semicircle, well, like the center of a circle is just halfway through its diameter, right? And this is the diameter of like the circle if you were to like complete the circle. So this is like kind of the center, right? And same here. So let's let the radius of the semicircle be like r. Then this is r, and this is r, and this is r. And the shortest distance between the two semicircles is just at the is like the distance right here, right? You can't get shorter than that, because if you choose like 2 like points on other otherwise, for example, if it's like here or here, that's like further, right? So the shortest distance is 2, right? And this is r, and this is also r. So this length will be 2r plus 2, right? And as it is like horizontal, it's parallel to AB and CD. That means this length will also be 2r plus 2. And like this length is just 2r. So the area is 224, and that is equal to 2r times 2r plus 2. Now we can divide both sides by 4. So 56 is equal to, so 224 divided by 4 is just 56, right? 2r, you can divide 2r by 2, and you can divide 2r plus 2 by 2. So 56 is r times r plus 1, right? Now you can basically just guess and check values. So r is equal to 7, right? Because 7 times 8 is equal to 56. There are no other solutions because otherwise r times r plus 1 would be too high or too low. We need to find the area of the shaded region. So the area of the unshaded region that's just the area. Like there are two semicircles. So if you combine them, that's a full circle. And the area of the unshaded region, which is the area of the full circle with radius 7, is equal to pi times 7 squared, which is 49 pi. And the area of the shaded region is just the entire area minus the area of the unshaded region. So the answer is 224 minus 49 pi. And you can, like, the contest allows you to use a calculator, right? So you can basically just plug that into the calculator, and then you can see that it is closest to it's closest to 70. Yeah, this contest allows you to use calculators, so take advantage of that, and you can see that's closest to 70, so the answer is E. And now we have a tournament, like, so Francesca, so this guy is equally likely to play any other player. If she plays against two of the other players, then the probability that she wins is that. And other 5 players, we have a probability too. So the probability that she plays Dominique and Estella, and then she wins, is 2 out of 5. 2 out of 7, because there are 7 possible other players, right? And you want to play like 2 of them. And the probability that Francesca wins is 2 over 5, which is 4 over 35. And the probability that Francesca plays against the other 5 players and wins is 5 out of 7 times 3 over 4, right? 5 over 7 is the chance that she plays any other 5 players, and the probability that she wins is 3 over 4. So that's equal to 15 over 28. The probability that Francesca wins her first match, that's just the probability that she plays the other 2 players and wins, plus the probability that she plays the other 5 players and wins. So because she can play any other player, right? So that's just 4 over 35 plus 15 over 28. We can make a common denominator of 140. So it's 16 over 140 plus 75 over 140. And that's 91 over 140. You can divide both sides by 7 to get 13 over 20. So D will be our answer. So for problem 18, Arturo finishes ahead of the other two people. So Arturo finishes first, right? So Arturo, when Arturo runs 2,000 meters, Morgan would have only ran 1,800 meters, right? Because the race is 2,000 meters long. And Henry would have only have ran 1710 meters, because that's 200 meters 290 meters less than 2,000. So if Morgan and Henry continue at their same speed, how far ahead of Henry will Morgan finish? So when Morgan finishes, Morgan would have ran 2,000 meters, right? And we need to find how much Henry would have ran. So Henry's speed in proportion to Morgan's speed is 1710 over 1800. And then you can see that is 19 over 20, right? So Henry runs so every 20 meters that Morgan runs, Henry can run 19 meters, right? So if you multiply both sides by 100, so 1900 equals that's equal to 1900 over 2000. So basically Henry's speed in proportion to Morgan's speed is 19 over 20, and that is equal to 1900 over 2000, 2000. So basically when Morgan runs 2000 meters, Henry can run 1900 meters. So when Morgan finishes, Henry would have only ran 1900 meters, and that's 100 meters behind of Morgan. So yeah, the answer will be B. So for question 19, the lines with these equations form a trapezoid, so we can just graph it. Sorry. So x equals 0 is just the y-axis. And y equals 0 is just the x-axis. And then y equals 2 is that line. That's also easy to graph. Y equals mx plus 7. That has a y-intercept of 7. So passes through 0, 7. Sorry. That passes through 0, 7. And m is greater than 0, so the slope, which is the slope, is positive. That means the line will be facing upwards. So let's draw the line. And yeah, so we know what the trapezoid is like now. And the area of the trapezoid is 3. And the distance between the lines y equals 2 and y equals 0 is 2. So the area is equal to base 1. This can be base 1 and base 2. Plus base 2 over 2 multiplied by height, right? So 3 is equal to base 1 plus base 2 over 2 multiplied by 2. So that means 3. Well, the 2 you can cancel out, right? So that means base 1 plus base 2 is equal to 3. And what's also equal to base 1 plus base 2 over 2 is the line halfway through the trapezoid, right? Because the line with y coordinate something, it's like the proportion between the length of the line in accordance to base 1 and base 2 is just how much it's like between y equals 0 and y equals 2, right? So the line that's like y equals 1, when it cuts the trapezoid, its length is base 1 plus base 2 over 2. And base 1 plus base 2 over 2 is equal to 3 over 2, right? That's just dividing both sides by 2. So it's equal to 3 over 2. And this is equal to, like, the length between this line and the point that we're given is 7 minus 1, which is 6. So the slope, now we can find the slope of the line, right? So the slope is the change in y, which is 6. Like when it goes from this point to this point, the change in y is 6, and then the change in x is 3 over 2. So that is equal to 12 over 3, which is 4. So the slope is 4, that means m is 4. So the answer will be C. And finally, we have problem 20. The product of the digits is equal to 200. So clearly this is a number theory like problem / combinatorics. But like whenever you have like a number theory like problem, you want to prime factorize it, right? Well, like the first this you like one can call this a combinatorics problem, but like the first part is like as its product is 200, it's like number theory, right? So 200 is equal to 2 to the power of 3 times 5 squared. And we need to find the number of integers whose product is equal to 200. So we can do casework, right? So notice, like if a digit cannot have both 2 and 5 as divisors, because then the digit would be at least 2 times 5, which is 10. And digits cannot be more than 10. Digits are single digit. So we can do casework. So if it's like so if one of the digits is 8, so notice the 5, like you must get 5 squared by multiplying 5 and 5. You can't multiply 5 squared because a digit cannot be 25, right? And 2 cubed. So case 1 is if 2 cubed is like if it's just like by itself. So the number can be like an arrangement of the digits 855, or it can be like 8551, or it can be like an arrangement of 85511. It cannot be like 111 more than that many ones because m is less than 10,000, so that means it can only have 5 digits. So for here, there are 3 ways to arrange it, right? And for here, there are 2 like repeated digits. So 4 factorial over 2, which is 12 ways to arrange it. And here it's there are repeated 5s and repeated 1s. So it's 5 factorial over 2 times 2, which is 30 ways to rearrange it. And case 2, you can also get a product of 200 by multiplying by getting 2 cubed with 4 and 2. And similarly, 5 squared, you must get 5 squared with 5 and 5. You cannot have like 25 or 1, right? Or it can be 4, 2, 5, 5, 1 in arrangement of that, because like multiplying by 1 is neutral, right? It doesn't change the product. The product will still be 200. So this gives 12 ways again. And this gives 5 factorial over, there's one repeated digit, so this gives 5 factorial over 2, which is 60 ways. And case 3 is if you can also get 2 cubed with 2, 2, and 2, right? You can multiply 2, 2, and 2. And to get the 5 squared, you still have to multiply 5 and 5. An arrangement of this, so there is 3 repeated 2's and 2 repeated 5's. So number of arrangements of this is 5 factorial over 3 factorial, as there are 3 2's over and in 2. Well, 2 factorial equals 2, right? As there are 2 repeated 5's. So it's equal to 120 divided by 12, which is 10 ways. So in total, there are 3 plus 12 plus 30 plus 12 plus 60 plus 10, which is 127 ways. And we're looking for the rightmost two digits. So that's 27. So that gives us the answer of B. So yeah, now we have finished all of the first 20 problems for Fermat. And we have taken around like 35 minutes. So that is like a good pace, right? That leaves you with 25 minutes to work on the final 5 problems. And then you would have like 5 minutes for like each of the final 5 problems, right? That is a good amount of time, and we have like a good pace right now. Yeah, I hope you enjoyed this video. Next part, we will continue to discuss the contest by the final 5 problems. Thank you.